Welcome back to C++ with Miyoshi. Today we're going to talk a little bit about math. Here we have a little math statement, and we know that this can never be true. I is equal to I plus 1. We know that can never be true because you can't have something equal to something plus something else. It can only be equal to itself. So that can never be true. However, as soon as we put a semicolon there, we know that it's a C++ statement, and we know that this guy here represents a memory location, as does this. The I is a memory location. We're going to add something to that memory location and stick it back into that same memory location. So here, if we have our little memory symbol over there, there's an I, and if we have I is 7 and we run this guy, it's going to put one more to it, add one more to it, and then it's going to stick it right back into I. So this is a perfectly legitimate statement in C++, and it's used quite often where we're going to add something to itself. Now in math, in programming, just like in math, we have the same operations. We have, and we also have the same order operations. So we have parentheses, exponents, multiplication, division, a new thing called the modulus, and then the addition and subtraction. So if we look at PEMDAS, just like we have in math, we might have an extra M in there for the modulus because that also follows the order operations. Now it also falls right in there with multiplication and division, and that's why I put in the M in PEMDAS, if you will. So remember, you can use parentheses to change the order operations. If you want to do an addition before you multiply, you have to use parentheses. We have exponents, which we're going to wait on a little bit with that. Know that you can still multiply numbers by itself over and over again to get exponents, but we're not going to worry about that yet. Multiplication, division, modulus, which we'll talk about in a minute, and it only works with integer variables and integer data. We have addition and subtraction, and it goes in that order. Okay? We have some other operators. These are called operators, except for these guys there. We also have these things called compound operators. And the compound operators are things like multiply, assign the value, divide, assign the value, modulus, assign the value, plus assign the value, minus assign the value. And those guys are compound operators. And what they do is they take a value like x, if we have x over here in our memory, and it's a 1.1, which I'll show you in a moment. And we're going to multiply that by 3. We can just do the compound operator and save ourselves a couple of keystrokes. So x times assign the value, it's going to take 3, then we're going to multiply our whatever's in there, multiply it by 3, and we get, that's our new value in our memory location. We have divide by, assign the value, multiply, assign the value, or modulus, assign the value, addition, assign the value, just like I said before. We also have these other cool operators, and they're the incrementer and decrementer. They just increment by 1 or decrement by 1. So add 1 to it or subtract 1 to the variable, and that's the plus plus and the minus minus operators. The plus plus operator is kind of how they got the C++ in the plus plus and the C++, because that was a new operator from C. Anyway, we have here's 3 different ways to write. If we're going to add 1 to a value, we can have 3 different ways. We have I is assigned the value I plus 1, I plus assigned the value 1, and I plus plus. Those all do the same things, and that is to add 1 to our value in I. Okay, we have J is assigned the value J plus 7, J plus 7. If we want to add 7 to a variable, we could do the same kind of thing, but we only have a couple ways to do that. J is assigned the value J plus 7, or the equivalent J plus assigned the value 7. There is no J plus 7. That doesn't work like it would be over here. It's just you have to do J plus assigned the value 7. And those would work with all our compound operators. Okay? One thing that's kind of different in programming than math, and that is division. Division actually is a little bit different depending on what data type you use. So if we're going to use floating data types, so floats or doubles, it operates just like you would expect it to. I have x assigned the value y divided by z. So if y is 3.4 and z is 5.6, so we're going to divide y, 3.4, by 5.6. We get exactly what you think we would. And we're going to do the math right here. Move those guys over. So here's my decimal point. So it's going to be 0.6 something. 6 times, that's 36, and that's a 3, so that's 33. So we have a 4. So it's 0.6 something. That's actually 0.60 something. And we could do that right over there. Okay? Let's get rid of that 40 for a moment. So that's just like we expect. So that 0.6, that's going to go right into our variable x. If we were going to do an a there instead, so maybe we're going to put this inside of an integer value instead, then things get a little different. In that case, if we did that, the value is going to get truncated. In other words, anything past the decimal place just gets ignored. It doesn't round or anything like that. All it does is truncates, get rid of it. And so if I put that into an a instead, that's going to give me just a 0. Okay, so let's put this back to x. We don't want to change that value right now. All right. Here, if we have, so that's kind of a neat thing. But if we have, it does the operation just like it would with a decimal number. However, since it's going to go, if we had that as an a again, it would just put that into my integer value as an integer, and it would just get rid of that guy. Okay, so it would just be a 0. If I'm going to put a y divided by a, so I'm going to do mixed division. Then if I do a floating point number divided by an integer, and I'm going to stick that into a floating point number, it's still going to do integer division and put that integer into x. So if here I have this guy here, y is 3.4, and I can divide that by a, which in this case is 3. So if I have 3.4 divided by 3, well, that looks like it's going to be 1 point something, 1.1 something. But in reality, since it's doing integer division, I'm going to get rid of that 1, and only the 1 is going to go into the x. Now that's going to be true whether x is an integer or float like it is here, or an integer. It's still just going to be a 1. In the case of a floating point number, it'll be 1.0, but it's still just a 1. Okay? If we have integer division, that means an integer divided by an integer, then it does something that you might not remember, except for it does something different than you might expect it to, especially if you've been doing math for a while. What it's going to do is we're going to look at the long division and I'll show you what it does by doing the long division. So if I have a as a sign of the value b divided by c, if b is 7 and c is 12, here's my division. I have 12 goes into 7, and I look at that and I say 12 doesn't go into 7. Well, it goes in 0 times. 0 times 12 is 0. 7 minus 0 is 7. Well, what happens here in my integer division, all I care about is the 0. So that 0 is going to come right over here, and that's going to be what's going to go into my a. Now here's the introduction to our modulus. The modulus is very similar to division, but it differs because all it's going to do is we just want the remainder. So when I do b modulus c, it does the same division, but now all I care about is the remainder. So in this case, 12 goes into 7 0 times. 0 times 12 is still 0. 7 minus 0 is still 7. The 7 is what comes over here and gets stuck into a in this case. Okay? That's what happens if the value is lower. What happens if it's higher? So if we divided c by b instead, we're going to do the same division. 7 goes into 12 one time. 7 times 1 is 7. 12 minus 7 is 5. And so the 1 is what gets put over here into a for my division. And the 5 is what gets put over here into a for my modulus. So, it's a little bit trickier. Not that much trickier, but it's a little bit different doing integer division than it is doing floating point division. And it's always fun to do some division with mixed numbers as well. If I divide by my float, I'm still going to get a float number, unless, of course, I'm going to stick it into an integer number, an integer variable. So, remember, a little bit of math, and it just follows our same kind of things we have PEMDAS, our order operations. We still have the same kind of things. We can do a little bit more now that we're using variables. We have these statements that look a little bit different than math, but they're very similar to math as well. So, hopefully now you can do a little bit of math. We got a little bit of output, a little bit of input, a little bit of math, and you can do a little bit of programming now to make some useful programs. And so hopefully you're going to be able to do that. So hopefully tune back in for more C++ with Miyoshi.